In the 1950s, long after the death of Alfred Wegener, scientists with new technology began discovering some interesting things on the Earth, and those things that they found began to support what Alfred Wegener felt like he already knew. Alfred Wegener came up with the idea that he called the theory of continental drift. And he had evidence to support the idea that the continents were not in the past where they are today, that they had moved. And with new technology and with new information, scientists used Wegener's ideas and came up with a new theory, the theory of plate tectonics. With the new technology that scientists had in the 1950s, they discovered between the United States and, or let's say North America and Europe and Africa, they discovered a ridge in the middle of the Atlantic Ocean. And the way they discovered this was they were taking drill samples along the ocean floor. And what they discovered was at the middle of the ocean floor was the youngest rock that was known on Earth. And as they moved away from the center of the Atlantic, in each direction, the rock got progressively older. And along the center, as they explored, they found an area that seemed to be volcanic, and there was mountains along the edges with a valley in between these mountain ranges. And what they now know is that this is what is known as the Mid-Atlantic Ridge. And what's happening at the Mid-Atlantic Ridge is new crust is being formed. And as the new crust is being formed, the Earth, or the crust, is moving, being pushed out in each direction. And so with this discovery, they were like, okay, well, new crust is being formed, which means somewhere on the Earth that crust is being destroyed. And so they knew about these areas in the oceans that had the deepest parts of the oceans, which were known as trenches. But scientists up to this point didn't understand what the trenches were. And there are a number of trenches. There's trenches along the coast of Washington and Oregon, and there's other trenches around the world. And again, they're the deepest parts of the ocean. And what they discovered after taking a second look is that this is where crust is being destroyed on the Earth. So we have crust being created along the mid-ocean ridges, and the mid-ocean ridges run all through the oceans. And generally in the middle of the oceans, very little do they come to the surface. But one place that they do come to the surface is in Iceland here, and we can actually see a mid-ocean ridge at the surface in Iceland. So with these discoveries, scientists realized that the Earth is cracked like a giant egg into large pieces, and these large pieces are called plates or tectonic plates. And in some places, the plates are moving apart. That's called divergent. In some places, the plates are moving together. That's called convergent. And in some places, the plates are sliding past one another, and those are known as transform. So again, we know that there are three types of plate boundaries along the tectonic plates. We have divergent plates, where the plates are moving apart. These are the mid-ocean ridges. The second type are convergent, where the plates are pushing together. Generally, but not always, this happens in the ocean. There are actually three types of convergent boundaries that we'll be talking about. And the last is a transform boundary, where plates slide past one another. This is an area where we experience a lot of earthquake activity, though earthquakes happen along all three types of these plate boundaries. We need to understand, before we move on, that plates are made up of the upper part of the crust of the earth, which is the lithosphere, and just beneath the lithosphere, the asthenosphere, which is basically the lower part of the crust and the upper part of the mantle. And there are two types of crust. There is oceanic crust, and the oceanic crust is generally thinner but more dense. And there is continental crust, and continental crust is generally a thicker crust, but it is less dense than the oceanic crust. So let's begin talking about plate boundaries, looking at the divergent boundaries. The divergent boundaries are along the mid-ocean ridges, and this is where the plates are moving apart. Now what happens is magma is pushed up from the mantle, and basically what happens is we have convection in the mantle, where the magma in the mantle slowly is convecting, and here we have two different convection areas that are moving the plates apart. Now, as those move apart, magma pushes up, creating new rock, and on either side of this valley, which is called a rift valley, we have the ridges or mountain ranges. So we one on each plate with the rift valley in between. These again are divergent boundaries. They are in the center of the ocean most of the time, though the mid-Atlantic ridge does come to the surface in Iceland, and where we can see and study it. And the second type of boundary we're going to talk about is a convergent boundary, where the plates are coming together. Now, there are three different types of convergent boundaries, and it depends on the type of crust that is colliding. In this first collision, we're going to look at continental crust colliding with continental crust. When two continental crusts collide, generally what happens is both crusts start to bend upward and push upward, creating what are known as folded mountains. Folded mountains. And the best example of a folded mountain is the highest mountain range in the world, the Himalaya Mountains. The Himalayas are a result of two continental plates crashing together. The Indo-Australian plate is crashing into the Eurasian plate and creating the Himalayas, and actually the Himalayas continue to grow larger by maybe a centimeter or two each year. The second type of convergent boundary is a convergent boundary where we have a continental crust and an oceanic crust colliding. Remember that the oceanic crust is more dense than the continental crust. So when those two collide, the continental crust will actually override the oceanic crust, and the oceanic crust is pushed back down into the mantle of the earth where it is recycled. Some of the features along a convergent boundary of oceanic and continental, we have the ocean trenches which form. This is where the oceanic crust is actually going back into the mantle. This is called subduction. It is being subducted back into the mantle. As that takes place, it stirs the mantle, and we have magma which starts working its way back to the surface on the continental side, and this will have an effect where volcanoes develop and occur. A good example of this is in the United States along the coast of Northern California and Oregon and Washington, the Cascade Mountains, which are all volcanic. And some of those volcanoes that you might know, Mount Shasta, Mount Rainier, and Mount St. Helens. There are there are hundreds of volcanoes along that coastline where we have two plates, the North American plate and the Juan Fuca plate are colliding, and the Juan Fuca plate is a small oceanic crust plate which is being subducted under the North American plate. Again, as this moves down, as the oceanic plate moves down into the mantle, it is known as subduction. Very important word. The third type of convergent boundary is when we have two oceanic crusts that collide. When two oceanic crusts collide, one, again, just like in oceanic continental collision, one of the crusts is going to be, or one of the plates is going to be pushed under or subducted under the other plate. Again, along that plate boundary, we will have a trench form, again, the deepest parts of the ocean. And on the side of the collision, where the crust that is not being subducted, you will have magma pushing up again, creating volcanoes or volcanic activity. But these are now oceanic, so they're in the ocean, and these volcanoes will create islands, which is known as an island arc. Couple of island arcs that you're familiar with, Japan and the islands of Japan are an island arc. Also, not far from us, Cuba, Jamaica, and the Virgin Islands, and all those islands that surround the Caribbean that too is an island arc. And the third type of plate boundary is known as a transform boundary. The transform boundary is a boundary where two plates are sliding past one another. Of course, they don't slide easily. These are gigantic, very thick plates that are crunched up against each other. One is trying to move one way because of convection in the mantle under the plate, and the other, same reasons, moving the other way because of convection moving under that plate in a different direction. pushing these two, trying to push these two past one another. Well, they don't slide easily, and they build up a lot of tension. Then when they do slide, we have earthquakes. Probably one of the most famous for us transform boundaries is the San Andreas Fault in California. The San Andreas Fault is a fault line that runs from about San Francisco down the coast towards Mexico, and it's where the Pacific plate is pushed up against the North American plate, and the Pacific plate is moving up towards the northwest, and the North American plate is moving towards the southeast, and those two plates create the San Andreas Fault, that boundary, and we're very much aware that there's a lot of earthquake activity that happens along there. But remember that earthquake activity can happen along any of the plate boundaries we have talked about, and in fact much larger earthquakes, though less frequent, they are much larger earthquakes, generally happen along some of the convergent boundaries than they do along the transform boundaries. So let's review for a minute. Remember, there are three types of plate boundaries. First, we have the divergent plate boundary, where plates are moving apart. Where that happens, mid-ocean, we have the mid-ocean ridges, and between the mid-ocean ridges we have a rift valley. New crust is being formed at these divergent boundaries. The second type of boundary is a convergent boundary. We have three types of convergent boundaries. The first is a continental collision, where folded mountains are created. The second type of convergent boundary is an oceanic continental collision, where we will have subduction taking place. The oceanic crust is subducted or pushed back into the mantle, where it is recycled or destroyed. At that boundary, we will have a trench form. We will have volcanoes on the continental side. And the third type of collision is an oceanic crust collision, where we will have, again, subduction take place. A trench is formed. Volcanoes again are formed, and these, since it's in the ocean, the volcanoes will create an island arc. And the third type of boundary is a transform boundary. Along transform boundaries, the boundaries are sliding past one another, and along those boundaries we will have frequent earthquake activity. All of this is driven by convection in the mantle, and the mantle is made of magma. Magma is a solid. It is molten rock, but under the pressure that it's under, it is solid, but it does have an ability to flow like a liquid. And the word for that is a solid with the ability to flow like a liquid is a solid that has a property called plasticity, which we will enjoy a lab about plasticity, and you will see and understand that property.